They found the station drifting. That's what the recovery team told me 6 months after I came back. Drifting with all its lights still on. Like someone had just stepped away from the desk for a moment. Like whoever had been there might still come back. I was that someone, and I hadn't stepped away. I had run. I'm not ashamed of that anymore. It took me a long time to get there, to a place where I could say the words without tasting the bile that comes with them. You spend your whole career being the kind of person who does not run. You build an identity out of steadiness. 31 years at the directorate, 17 deployments beyond the heliopause, 3 commendations for cold weather survival on the Titan outposts. You become, in your own mind, the man who holds the line. And then something comes along that rewrites everything you thought you knew about lines, and about who holds them, and about what it means to survive. Let me start at the beginning. Not because the beginning is dramatic, it isn't. The beginning is slow. It is very, very slow, and for a long time it is boring, and I think that's part of what made it so dangerous. We were not looking for something that could hurt us. We were looking for something that had hurt everything before us, and we assumed the past tense mattered. The station was called Perimeter Actual, not a romantic name. No one at the directorate was in the business of naming things romantically. It was the third iteration of long baseline infrared observation platforms placed at the outer shell of the cloud, the vast, cold halo of rock and ice that surrounded our solar system at distances that made the planets seem like they were sitting in the same room. If you held up your thumb and blotted out the sun from where we were stationed, everything humanity had ever built would disappear behind your thumbnail. Every war, every city, every grave. Gone behind a centimeter of your own skin. The cloud itself had a name, technically. Scientists had one for everything. But we called it the cloud because that's what it looked like on the old survey maps, a smear of density at the edge of the instrument's reach, billions of objects too distant and too dark to resolve individually. Comets in cold storage. That's what it amounted to. Trillions of icy bodies, parked at the edge of the solar system in the long, slow pause between trajectories. Most of them would never move in any direction that mattered. Most of them had been sitting in roughly the same orbit since the system formed, 4.5 billion years ago. Most. There were 7 of us at the station. I was the senior analyst. The others were younger, 5 scientists and 1 medic, a woman named Vasquez who had the useful habit of making terrible coffee and the less useful habit of telling everyone exactly what she thought of their work. We had been deployed for 11 months of a 14-month cycle when the data started coming in wrong. Not dramatically wrong. I want to be precise about this, because people who weren't there tend to imagine some kind of alarm going off, some cinematic moment where we all look at each other with wide eyes. It didn't work like that. What happened was that my junior analyst, a young man named Price, came to me one morning during the quiet shift and said, in the tone of a man reporting a software glitch, that his infrared sweep of Survey Sector 7 was showing thermal variance he couldn't account for. I told him to rerun the calibration sequence. He came back 3 hours later and told me the calibration sequence had returned clean results. The variance was still there. I looked at his numbers. They were subtle, a ghost of a heat signature at the outer edge of the cloud, maybe 1.3 light-years out, far enough that even our best instruments had to strain to see it. But it was there, consistent across 3 consecutive sweeps, and it was moving. Not fast, not in any way that suggested urgency. It was moving the way continents move, with the patience of something that has no reason to hurry. I filed it under anomalous and went to sleep. That's the thing no one puts in the mission reports. You get tired. You work for 11 months in a tin can with 6 other human beings, at the absolute edge of the space your species has ever occupied, and the instrument panels blur and the numbers stop meaning anything and your body just wants to lie down. The anomaly had been there, presumably, for a very long time. It would still be there after I slept. I've thought about that decision many times since. I don't know if it would have changed anything, but I think about it. In the morning, Price had brought in Castellan, our astrophysicist, and together they had filled 3 wall panels with data. I stood in the doorway of the analysis room with my coffee, Vasquez's coffee, which tasted like she'd filtered it through regret, and looked at what they'd built, and felt the first cold thing move through my stomach. Castellan was the best scientist I'd ever deployed with. I've worked with a lot of scientists in 31 years, and the best ones all share a specific quality. They do not bend to what they want to find. They are loyal to the data even when the data is inconvenient, especially then. She had that quality in abundance. She had a habit of speaking slowly when she was working through something difficult, the way a person might speak slowly when they're carrying something heavy, making sure of each step before they take it. She spoke slowly now. The signature wasn't a comet. We'd cataloged thousands of comets during that deployment. I knew what comets looked like on infrared. This was different. It had mass. It had a consistent thermal gradient, not the kind you got from a chunk of ice warming as it fell inward, but the kind you got from something that generated its own heat. Faint, very faint, but there. Castellan was trying to be calm about it. She was the kind of scientist who performed composure as a professional reflex, and she did it well enough that most of the time I believed it. But her hands were doing something strange on the console, pressing keys she didn't need to press, pulling data she'd already pulled. And I recognized it as the motion of someone who needs to stay moving so they don't have to stand still and think about what they're looking at. "It's a brown dwarf," she said. "Has to be. Uncharted. We've got incomplete coverage of this sector." "Mass estimate?" I asked. She pulled the number up. I looked at it. I understood what she was doing by calling it a brown dwarf. A brown dwarf was something we had a protocol for. A brown dwarf was something you logged and tagged and sent a report to the directorate about, and then got on with your day. What she was looking at was in the low end of the red dwarf range, dim enough to have been missed if you weren't looking in the right frequencies in the right place at the right time. Dim enough to have been missed by every survey that had run before ours, which were many. Dim enough to have been hiding, if a thing without intention can be said to hide. "How long has it been in this position?" I asked. Price answered before she could. He'd been running comparison checks against archived survey data, years of it, pulled from the station's deep storage from previous deployments. His voice was careful. Young scientists learn to be careful when they're about to say something that reorders the room. They learn that some sentences, once spoken, cannot be walked back, and that the room is different after them. "I've got a partial track," he said. "I can put it back about 400 years, give or take. It's on an elliptical. The ellipse is it's large." "How large?" He told me. He used numbers. I will tell you what those numbers meant instead. The orbit, if Price's numbers were right, would take approximately 26 million years to complete. At the far end of the ellipse, where the object would swing deepest into the interior cloud, it would pass close enough to the densest comet populations to do something very specific. It would disturb them. Gravitationally. Systematically. The way a hand dragged slowly through still water creates a wake that reaches every edge of the container. It would alter orbits, redirect trajectories, dislodge bodies that had been sitting still for millions of years, and send them falling inward, toward the inner planets, toward the one planet in particular that had, in its last 2.5 billion years, developed a thin film of life on its surface. Castellan said it before I did. She said it flatly, like a woman who has been holding a word in her mouth for several minutes and is finally ready to let it out. Every major extinction event in Earth's geological record. They cluster at intervals of approximately 26 million years. The room was quiet for a moment. "Yes," I said. "More quiet." "So this is it," Price said. "This is what did it." "Possibly," I said, because I was his senior analyst and he was young, and I was not ready to say anything beyond possibly to a 28-year-old who still had the look of a man who thought the universe was basically a problem that competent people could solve. Not because I wanted to protect him from the truth, because possibly was all I was willing to commit to out loud in that moment, in that room. The rest of it was already forming in my chest like something hardening. I knew, I knew what we were looking at, not a theoretical construct, not a model built from fossil records and statistical inference and the elegant mathematics of men and women who had spent their careers arguing in academic journals. We were looking at the thing itself, the object that had redirected the extinction of the dinosaurs, that had cleared the Permian world, that had reshaped the oceans of the Devonian and the forests of the Ordovician and the shallow seas that had, hundreds of millions of years before any of us were born, held everything that was alive. We were looking at the architect of death by accident, by simple, cold, gravitational arithmetic, no malice, no intelligence, no awareness that anything lived on the third planet of the warm star it slowly orbited, just mass and momentum and the patient mathematics of gravity working at scales that human beings were not built to feel in their bones. I called the directorate. It took 11 hours for the signal to reach them and 11 hours for the response to reach us, and what came back was what you would expect from an institution whose first response to anything unprecedented is to form a committee. They wanted us to continue observation. They wanted redundant data. They wanted, above all things, for us to not do anything until they had convened a panel of appropriate experts and arrived at a consensus position. I acknowledged the order. I told Price and Castellan to continue observation. I went to the observation port at the end of the main corridor, a half-meter circle of reinforced glass that looked out at nothing, at the absolute black of the outer system. And I stood there for a while and tried to think about what I actually felt, as opposed to what I was professionally obligated to feel. Here is what I knew at that point. The object was approximately 1.3 light-years away. It was moving, but on its current track, it would not begin its closest approach to the densest portion of the cloud for another several thousand years. The danger was not immediate. The geological clock moved in millions of years, not in human lifetimes. No one on Earth would live to see the next passage. Their grandchildren would not see it. Not their grandchildren's grandchildren's grandchildren, reaching down 20 generations into the future. But knowledge has weight. It doesn't matter whether the danger is immediate or whether it is 1,000 years away or 1,000,000. Once you know the shape of a thing, once you can see it with your own instruments and put numbers to it and trace it back through the fossil record, and understand that it has already killed everything that has ever died on the world you were born on, it changes you. The weight of it is different from intellectual understanding. Every physicist on Earth could work out the mathematics of a Nemesis-class object on a blackboard. We had been doing it for decades, theoretically, hypothetically, building models of an object we hadn't confirmed, arguing about orbital mechanics and extinction periodicity and the completeness of the fossil record. But to see it at 1.3 light-years, moving with that slow, patient, utterly indifferent trajectory, that was something else. That was the moment when the hypothesis became a thing that existed in the world. The moment when theoretical became real. It had a location. It had a temperature. It had a mass and an orbit and a history measured in the bones of dead species. I was still standing at the port when Vasquez came and stood beside me. She was not supposed to be on shift. She'd come because she'd heard the brief I'd given to the crew, sitting them all down in the common room and walking through it the way you walk through an emergency protocol, clearly, in order, without embellishment. She'd been quiet during the brief, hadn't asked any questions, but now she stood beside me with her terrible coffee and looked at the dark and didn't say anything for a while. After a while she said, "It's not alive." "No," I said. "It doesn't know we're here." "No. It's not trying to hurt anyone." "No." She nodded slowly. Then she said the thing I had been turning over in my own head for the last 3 hours. "So why does it feel like it is?" I didn't answer. I didn't have one, but I understood exactly what she meant. There is a particular quality to a threat that is patient. Human threats are urgent. Human threats shout, mobilize, strike deadlines, issue ultimatums. They want to be seen. What we were watching operated on a schedule so vast it didn't require any of those things. It simply moved. It had simply moved. For 4.5 billion years, it had traced its great ellipse around the sun, and every 26 million years or so it had passed through the cloud, and the comets had shifted, and eventually some of them had fallen inward, and eventually some of those had struck, and every strike had been different, and every difference had determined who survived and who didn't, and who survived had become the next layer of life, and then it had started again. And we were the current layer. The thought that kept coming was this: we were here because it had passed before. Everything that had survived the previous passages, every organism that had crawled or swum or flown or walked its way through to the present day, had made it because of chance, or because of where they'd been, or because of what they'd eaten, or because of how fast they'd evolved in the aftermath. And the thing that had driven all of that chance had been this object, dim and cold and slow, following the same arc it had always followed, not knowing and not caring that in its wake it had designed every living thing that would ever be. Price knocked on the frame of the port. He had more data. We went back to work. Over the next 3 weeks, we built the most complete track of the object that had ever been assembled. I sent daily reports to the directorate. They sent back requests for additional verification. I understood the instinct. Any government body faced with news of this magnitude will reach first for the possibility that the news is wrong. The possibility of error is, for a while at least, more comfortable than the alternative. I had spent 20 years watching institutions process uncomfortable information, and I understood that the processing has to happen before the response can happen, and that rushing the processing tends to produce worse responses. The numbers held. Every calibration confirmed them. We pulled archived data from the previous 2 station deployments, from survey satellites placed in the outer system over the last 60 years, from a ground-based infrared telescope project that had been running in the southern hemisphere for the last 40 years, and had a portion of its survey area that overlapped our current sector. We ran comparisons across all of it. We built redundant analyses using different methodologies. We had 2 of our scientists check each other's work without sharing results first, and then compared what they'd produced independently. The numbers aligned each time, within expected margin of error. The object was real, the orbit was real, the interval was real. We were not making a mistake. On the 22nd day, I got a personal message from one of the directorate's senior analysts, a man I'd worked with during my first deployment, a long time ago. He was not writing in an official capacity. He made that clear. He was writing as one person to another, which is usually how the things that matter get communicated when the official channels are too slow or too cautious to carry them. He wrote, "The committee has confirmed your findings." He wrote, "The full scope of the analysis is being escalated." He wrote, "There are conversations happening at levels above what I have access to." He wrote, "I want you to know that what your team has done is something that has never been done before, and I'm not sure any of us fully understand what it means yet." That last sentence stayed with me. Not because it was surprising, I'd been living with not fully understanding for 3 weeks, but because it was honest, and honesty from that particular man in that particular context meant it was being said because it needed to be said, not because it was easy. I understood what it meant. I'd been understanding it for 3 weeks. But there's a difference between understanding something alone in a station at the edge of the solar system and having someone on Earth acknowledge that the understanding is shared. It made the weight heavier somehow, not lighter. Shared weight is still weight, but it's weight that belongs to more people, and that matters. I showed the message to no one. I filed it. I went back to work. The break came on day 31. We'd been doing redundant sweeps of the track, building out the positional data, when Castellan flagged something in the near-cloud data, the denser inner region, closer to the system, which we'd been monitoring as a control baseline. She'd found an anomaly there too, not the same kind. This wasn't a thermal signature. This was a mechanical one, the kind of displacement you got when an object that had been in a stable orbit for a very long time had its trajectory altered by something external. A comet, a large one roughly 30 kilometers across, which put it in the category of objects we generally preferred not to think about in terms of what they'd do if they hit anything. Its orbit had been shifted, not dramatically, not in a way that would have shown up on a casual survey. The displacement was subtle. Castellan found it only because she was looking for it specifically, because the discovery of the object had made her want to understand the full range of its influence, and she had been methodical about the search in the way that careful scientists are methodical. No shortcuts, no assumptions about what was worth checking. She ran the numbers 3 times and came to me on the third run with the look of a woman who has been told something she would prefer not to have been told, and knows she has to tell someone else. The comet's orbit had been modified. Not recently, the modification had occurred approximately 8,000 years ago, based on the trajectory mathematics, before anyone had been watching, before our instruments existed, before the station existed, before the directorate existed, before any human being had ever put a machine in space, or pointed a telescope at the sky with any serious intention of understanding what they were seeing. Something had nudged it, something at sufficient distance to affect the trajectory without appearing to do so. The object, at the far end of an influence that reached across a light year and a quarter, through the cold dark, through 8,000 years of slow orbital drift, to a comet that was now sitting on a trajectory that would bring it significantly closer to the inner system than it had been before. "It's not just passing through," Castellan said. "The gravitational reach at this distance, it's affecting the cloud continuously, not strongly, not enough to see without dedicated monitoring, but it's not dormant between passages, it's always pulling." She showed me the mathematics. I checked them. She was right. The distinction matters. The existing models had assumed the object's influence was periodic, worst during closest approach, negligible between passages. A tide that came in during the close approach and receded completely in the long intervals between. What Castellan had found suggested the influence was constant. Subtler between passages, yes, but not zero. The cloud was always responding, the way a bowl of water responds to someone's fingertip resting on its surface. Not a wave, just a slight, permanent warping of the level. Always there, always working. "How many comets are affected on the continuous model?" I asked. She gave me a number that I am not going to write here because it is the kind of number that, taken without context, would be irresponsible. What I will say is that the number was sufficient to alter the inner system impact rate by a small but non-trivial percentage on a continuous basis, and that this continuous background effect, compounded over geological timescales with the periodic spike of close approach, was more than enough to account for the complete extinction record. Every single one. I sat with that. I sat with the specific, concrete meaning of it, not in the abstract, not as a statistic, but as a list of things that had existed and then stopped existing. The mass extinction that ended the Ordovician period, 445 million years ago. Whatever lived in those ancient seas, things we know only from fragments, from compressed traces in stone, reduced by more than 85%. Gone. Because of a series of impacts that happened because of altered comet trajectories that happened because of the subtle gravitational finger of something 1.3 light-years away. The one at the end of the Devonian, roughly 375 million years ago, which destroyed 70 to 80% of all species on Earth. Fish, mostly. The world that produced fish, the long golden age of vertebrate life in the oceans, ended. The Permian, 252 million years ago, the largest die-off in the planet's history, 96% of all marine species, 70% of all terrestrial vertebrates, things that had been the dominant forms of life on Earth for tens of millions of years, gone so thoroughly that the recovery took 10 million years and the world that came back was barely recognizable. Because of impacts, because of altered orbits, because of something that did not know they existed. The Triassic event that cleared the way for the dinosaurs. The event 66 million years ago that ended them, which is the one everyone knows, which is the one that cleared the way for the small, warm-blooded, night-adapted mammals that would eventually become us. All of it, directly or indirectly, close approach or background influence or some combination of both, all of it. I called the directorate again. I didn't wait for the regular report window. I opened a priority channel and sent the full data package, and then I sat in the communications room alone, in the quiet that a priority channel leaves behind it, and waited. What I did while I waited was make a list. Old habit from early in my career, a supervisor told me once that a person who writes things down is a person who understands that their memory will fail them and has chosen to respect that fact. I started the habit young and never broke it. The list I made was of the specific things we had confirmed, in order, with the date of confirmation and the name of the team member who had done the confirming. It was a short list. It didn't need to be long. 1. Infrared thermal signature at 1.3 light-years, consistent across 22 consecutive sweeps, confirmed by both Price and Castellan independently. 2. Mass estimate placing the object in the red dwarf range, DMEND, sufficient to account for persistent gravitational influence at distance. Confirmed Castellan. 3. Orbital track partial, built back approximately 4 centuries, matching an elliptical period of approximately 26 million years. Confirmed Price. 4. Correlation between the 26 million year period and the established geological record of mass extinctions on Earth. This one I'd confirmed myself, cross-referencing against the paleological literature in the station's scientific database, literature that had been placed there for exactly this kind of purpose, years before our deployment, by someone who had understood that instruments placed at the edge of the solar system might one day find something worth comparing against the deep record of Earth's history. Whoever had built that database had been thinking about the same question we were now answering. I was grateful to them. I didn't know their name. 5. Continuous gravitational influence on near-cloud comet populations, demonstrated by displacement of a 30-kilometer body over an 8,000-year period. Confirmed Castellan. I looked at the list. 5 points. 5 specific, verified, reproducible facts that, taken together, meant something that no previous list of verified facts in human history had meant. I folded the paper, actual paper, not a screen. I kept a notebook and put it in my breast pocket and sat in the quiet of the communications room and waited for Earth to respond. This is the part of the story that is hardest to tell. Not because of what happened next. What happened next was almost anticlimactic, as the responses to very large events so often are, because the people doing the responding are just people, doing the human things that people do when something is too large to respond to all at once. The hard part is what happened in me during those 11 hours of waiting. Because I had time to think, and the thought I kept arriving at was the same thought that I imagine every person arrives at when they truly confront the depth of time, not as a concept, not as a number, but as a felt thing, a weight, a presence in the room with you. We were not an accident, not in the way people usually mean that word. We hadn't happened in spite of the extinctions. We had happened because of them. The removals, mass, systematic, catastrophic, had cleared ecological space, had eliminated competitors and consolidated survivors, had forced the survivors into new niches, new pressures, new evolutionary paths that they would not have taken in an undisturbed world. The great dying that killed the dinosaurs had opened the world to the small, warm-blooded, night-adapted creatures that had been surviving on the margins of the dinosaurs' world for 100 million years. They'd been there all along, those tiny mammals, hiding, waiting, and when the clearing came, they were ready for it, not because they'd anticipated it, but because survival selects for readiness in ways that are invisible until after the fact. We existed because every previous tenant of the planet had been evicted, and the evictions had been scheduled, even if no one was keeping the schedule deliberately. I'm not a philosopher. I'm a survey analyst. I spent 3 decades looking at data and writing reports, but sitting in that communications room, waiting for Earth to respond, I felt something that I don't have a better word for than vertigo. Not the spatial kind. The kind you feel when the ground of your assumptions drops away and you realize you're standing in midair, and have been standing there for a while and only just noticed. We had never been alone in shaping our own history. Something else had been shaping it, not with intention, not with malice, not with any awareness that life existed on the third planet of the warm yellow star it slowly orbited, with nothing but the mathematics of gravity and the cold patience of a very long orbit. But it had been there at every critical juncture, the moments when everything could have gone differently, when the dominant form of life could have consolidated its grip and made it impossible for something new to emerge. It had broken those grips, again and again and again. And now we were here, looking at it. The response came in the 11th hour, almost to the minute. It was not from a committee. It was from the director herself, which told me the weight of the situation had finally landed at the level where it belonged, and that someone in authority had made the decision to stop processing through channels and speak directly. She authorized continued observation. She authorized expanded survey parameters. She told me that additional stations were being repositioned to provide overlapping coverage of the object's track, and that a manned deep survey mission was being planned for closer approach, though closer was relative, and the timeline for that mission was measured in years. She told me that my team's work would be fully classified at the highest level, not to suppress it, but to allow time for proper analysis before public disclosure, and that the disclosure was coming, sooner rather than later, because there was no world in which this stayed quiet, and she preferred it to come out in an organized way from the people who understood it. And then she said something that I have thought about every day since. She said, "You have found the mechanism. Now we need to find the response." I sat with that for a long time. I turned it over. I thought about the specific choice of words. The mechanism, the response. As if it were a problem that could be solved. As if the finding of a thing implied the existence of a solution to the thing. As if humanity's first instinct, when confronted with an overwhelming cosmic force, was always and could only ever be, all right. We see it. What do we do about it? And the thing is, she was right. Not because there's a solution ready, not because the response is simple or near or already designed, but because the question is the right question, and asking the right question is where all answers begin. You can't respond to a mechanism you can't see. You can't build a plan for something you haven't named. We had named it. We had measured it. We had traced its history through 4 billion years of fossil record. The response could not have started before the naming. I thought about the dinosaurs. I thought about the Permian creatures, the things that had lived in those shallow seas and that dense, warm, impossibly full world, the things that had been so successful, so thoroughly established, so entrenched in every ecological niche that they must have seemed, to any observer, like permanent features of the planet. And then I thought about the thing outside, tracing its slow arc, and I thought about how much effort they had put into survival in the ordinary sense, outcompeting, adapting, defending, eating, reproducing, growing, and how none of it had mattered when the schedule came. And then I thought about us, about what we had done that they hadn't. We had looked, not just lived, not just survived one crisis at a time, reacting to immediate threats, adapting to immediate pressures. We had pointed instruments at the dark. We had built machines capable of detecting a dim, cold star 1.3 light-years away by its faint infrared output. We had assembled decades of archived survey data and run comparison analysis, and noticed a displacement in a comet's orbit that had occurred 8,000 years before any of our instruments existed, and we had worked out, from first principles, what had caused it. We had looked at the fossil record and asked not just what had happened but why, and we had kept asking that question for generations, and we had sent people to the edge of the solar system to try to find the answer. No other species had done that, not as far as we knew. Not the Permian creatures, not the Devonian fish, not anything that had been cleared away before us. They had been alive. They had been complex in their own ways. Some of them had been, by any reasonable measure, successful. But none of them had ever looked at the extinction record and asked, is this periodic? Is there a pattern? If there's a pattern, is there a cause? And if there's a cause, can we find it? We were the first things, in 4 billion years of continuous life on that planet, to understand the mechanism of their own potential extinction, to look at it, to name it. That is not a small thing. It doesn't save you. Understanding doesn't save you, not by itself, but it is the prerequisite for everything that might. Price knocked on the door again. He had more data. He always had more data. We went back to work. The last 2 months of the deployment were different from the first 11. Not quieter, we were running more sweeps, more analysis, more comparison checks than we'd done in the entire preceding year. But the quality of the work had changed. There was a direction to it that hadn't been there before. Not urgency in the immediate sense. The object was not going to arrive in our lifetimes, or in our children's lifetimes, or for a very long time after that. But we were building something. We could feel it. The sense that the data we were generating had a purpose that extended beyond the usual metrics of the mission report. That someone, someday, would use what we were making. That the using mattered. Castellan developed a predictive model for cloud disruption, a map of which comet populations were most vulnerable to sustained gravitational influence from the object's current position. It was the kind of model that a mission planner could use in a few thousand years to identify specific objects worth monitoring, specific trajectories worth redirecting if the technology existed. She knew that. She built it with that future use in mind, even though she would never see the use. Price refined the orbital track to within a margin of error so small it was nearly academic. But nearly academic is not academic, and in the context of something moving on a 26 million year cycle, the difference between a good estimate and a precise one compounds over time in ways that matter. He knew that too. He was 28 years old, and he had figured out, in the course of 3 weeks, that he was doing work that would outlast him by millions of years, and instead of finding that paralyzing, he found it settling. It gave him a sense of proportion about the small daily frustrations of the work. Akafer, our communications specialist, who had barely spoken in 11 months, who had been quiet and competent and invisible in the way that good communications specialists often are, spent his off hours building a visual representation of the orbit that could be understood without technical training. He had a gift for it that I hadn't known about, because I hadn't asked. He could translate a data set into a shape that a non-scientist could feel, not just see. He spent 3 weeks on that visualization, and it was, when he finished, the clearest explanation of what we had found that I saw in any form, from any source, in all the years since. There was an afternoon, about 6 weeks into the intensive work, when we all hit the wall at roughly the same time. I think it happens on long deployments when a high-pressure event saturates the crew. You can sustain elevated performance for a while, weeks even, but at some point the body starts presenting the bill. I noticed it in the common room at the end of a shift. Price was staring at his coffee without drinking it. Castellan had the same 3 equations on her tablet that she'd had for 2 hours and hadn't advanced them. Akafer was looking at the wall. I looked at the wall too for a moment, because sometimes that's all there is to do. What I was thinking about was this. The object had no name, not an official one. We had filed it under a survey designation, a string of numbers and letters that identified its position in our cataloging system and meant nothing to a human being not familiar with that system. In every report I'd written, I had referred to it as the object, because that felt accurate and neutral, and because I had an instinct against naming things that you might be tempted to personify. But humans name things. We always have. It's how we hold things in our minds. And I had noticed in the weeks of work that the crew had started referring to it in shorthand, not the survey designation, which was cumbersome, and not the object, which was what I used in official documents, but a word that had come into use without anyone deciding it should. They called it the traveler. Not as a gesture of friendliness, not out of naivety, out of an accurate descriptive instinct, because that is what it was. Something that had been traveling for a very long time on a very long route and had been doing so since before any of us existed in any form. Price had used it first, I think, or maybe Akaffer. It spread the way informal language spreads on small stations, without announcement, as a natural development, until one day you notice that everyone is using the same word and you can't remember who started it. I never used it in a report, but I thought it sometimes. The traveler was 1.3 light-years away, and it had been traveling for 4.5 billion years, and it was going to keep traveling for millions more. We had found it. We had named it in our way, the way humans name things they want to hold onto. And we had started to understand in the week before the extraction that finding and naming was only the beginning of the obligation. Vasquez kept making terrible coffee and asking the questions none of the scientists wanted to ask. "Can we deflect it?" she asked one evening in the common room. We were all there, which was rare. The deployment schedule rarely aligned everyone's downtime. But we'd finished a long shift and the food had come out acceptable, which was enough of a celebration to keep people sitting. "It's a star," Price said. "I know what it is." "We can't deflect a star." "We can barely deflect a medium-sized asteroid," Castellan said, setting her coffee down. "We once had an international crisis over one that turned out to be a small one." "So that's a no," Vasquez said. "That's a no," I confirmed. "Can we deflect the comets, the ones it kicks loose?" Silent, this one was harder to dismiss. "In theory," Castellan said slowly. "In the very long run. If we're talking about the next passage, thousands of years from now, and if we have a way to identify which comets are going to be displaced well in advance, and if we have the technology to reach them at that distance and apply sufficient force at sufficient range." "That's a lot of ifs." "Yes. So the answer is not yet." "The answer is not yet." Vasquez nodded. She had the look of a person who has heard a difficult answer and found it, on reflection, acceptable, not because the answer was good, but because not yet was better than never. Not yet was a direction. Not yet was something you could work toward. "Then we'd better get busy," she said, and went back to her coffee. That was the thing about her. She had no patience for despair, not because she was naive, she wasn't. She'd read the same data we had, sat through the same briefings, understood the same scope of what we were looking at. But she had this absolute, almost aggressive refusal to treat understanding as the final stop. For her, understanding was the starting line of the actual problem. The actual problem was what you did next. I've thought about her a lot since we came back. About that quality, where it comes from in a person, whether it's born or built, whether it can be cultivated or only modeled. What I believe now is that you can't teach it, but you can demonstrate it, and demonstration has more influence than teaching, and what gets demonstrated enough times becomes the standard. She demonstrated it every day for 14 months, in small ways and large, and I think everyone on that station was slightly different because of it. The extraction came 2 weeks before the end of the official deployment cycle. The directorate had sent a message. The mission was being formally extended, but they wanted the current crew rotated out first. A new team was already en route. 12 people, 3 times our number, with better instruments. We had 12 days of overlap scheduled for data transfer and briefing. 12 days felt very short for everything we had to pass on, but it usually does. We worked through most of them without sleeping much. Castellan documented the disruption model in enough detail that a competent astrophysicist could pick it up cold and continue it. Price wrote the most thorough observational log I'd seen in 31 years of deployment, and he wrote it in plain language, without jargon, because he understood that some of the people who would eventually read it would not be scientists. HFY transferred the visualization, which needed no translation. It spoke for itself. I wrote the summary report. It took me 3 days, and I rewrote it 4 times because every time I finished it, it felt too small for what it was describing. I wrote it clinical and it felt inadequate. I wrote it with more weight and it felt indulgent. In the end, I did what analysts do. I wrote the facts clearly, organized them logically, and trusted the reader to understand that facts like these carry their own weight. You don't need to tell a person that something is serious if you explain it precisely, and they have the capacity to understand what they're reading. On the last night before our transport departed, I went back to the observation port. The dark outside was the same dark it had always been, absolute, without bottom. The object was still out there at 1.3 light-years, moving at the pace of something that has no schedule to keep. From where I stood, I couldn't see it. No human eye could see it at that distance, dim as it was, cold as it was. Everything we knew about it had come through instruments, through data, through mathematics, through the patient, accumulated effort of human beings who had refused to accept that a pattern without an explanation was just a mystery you learned to live with. But I knew where it was. I knew its orbit. I knew its mass and its approximate luminosity and the arc it had been tracing since before Earth had oceans. And knowing all of that, I looked at the dark in exactly the direction where it was, and I thought, we see you. That's all, just that. We see you. There's something to that. Something that matters, even if I can't defend it on a technical level. The object does not know. It cannot know. It has no awareness of being seen, no capacity to be seen differently because of the seeing. It continues its orbit whether we observe it or not, and will continue it long after every instrument we've built has gone dark, long after this station has been reclaimed by the slow drift of the outer system, long after the records we have built today have passed through the hands of so many people that no one remembers who first looked. But we are the first things that have ever said it. In all the billions of years of the solar system's history, through all the extinctions and recoveries and extinctions again, through everything that lived and struggled and bred and died in the ordinary way that living things do, nothing that lived here ever developed the capacity to look at the mechanism of its own destruction and say, we see you. We understand what you are. We know what you've done, and we know what you'll do, and we are not finished yet. That's the thing about us. It's the specific thing. Not our intelligence in the abstract, not our tools, not our cities or our mathematics or our history of cooperating badly but eventually cooperating. All of those things matter, but the specific thing, the thing that separates us from every organism that went before us on that small, unlikely planet, is this: we look. We look at the things that can kill us. We measure them, we name them, we argue about them. We build instruments to see them better and deploy people to the edge of the solar system, to sit in a metal container for 14 months because we believe, fundamentally, that knowing is worth the cost. That understanding is not the end of the problem but the beginning of the response. That the response will outlast all of us, and that this is not a reason to stop, but the best possible reason to start. The transport docked at 600. We transferred the data and briefed the incoming team. I shook hands with their lead analyst, a woman about Price's age who had the focused energy of someone who has been waiting for exactly this assignment. She had already read our reports, all of them. She had questions that were specific and sharp, the kind that come from having read everything and thought about it seriously. I answered them. I told her what I wished I had known at the start of the deployment. She wrote it down. We left. The passage home was long, 8 months. I spent most of it sleeping badly and reading the reports as they came in from the station. The new team was generating data at 3 times our rate, which should have been purely satisfying and mostly was. The picture was filling in. The picture was very large. What I thought about, in the long months of transit, was the question the director had asked. The mechanism, the response. I don't know what the response is. I'm not qualified to design it. That's a question for engineers and physicists and people who build large things over long timelines. I know it involves time in quantities that are difficult to reason about. I know it requires a continuity of civilization sufficient to maintain focused, serious effort across thousands of years, which is its own enormous challenge, maybe the central challenge, the one that dwarfs all the others, because we have never yet sustained anything for that long. Our longest institutions are a few thousand years old, and most of them are unrecognizable to their founders. The problem does not require urgency in the immediate sense, only in the civilizational sense. Only across enough generations to matter. That is not guaranteed. Nothing is guaranteed. The thing outside doesn't need us to fail. It just needs to keep moving, and eventually it will get close enough. And if we haven't prepared, if we've lost the thread, if we've decided that looking at the long problem is someone else's job, if we've turned inward in the way that civilizations turn inward when things get hard and the long horizon disappears, then the outcome will be the same as it was for everything before us. Except that we'll have known, and we'll have chosen somewhere along the way to stop looking. I think about that more than I think about the object itself. We docked at the Inner System Transfer Station in late autumn, by Earth reckoning. I went through debriefing. 3 weeks, extensive, conducted by people who were already deep into the questions of public communication and scientific coordination, and the long institutional machinery of what happens after a discovery that cannot be undiscovered. I gave my testimony. I handed over my personal logs. I answered every question, including the ones that didn't have good answers, including the ones that were really just people asking the same question I'd been asking since day one. What do we do with this? At the end of the 3rd week, one of the debriefing officers, a young man who'd been taking notes throughout, looked up from his console and said, seemingly without meaning to say it out loud, "What do we do with this?" He wasn't asking me professionally. He was asking me the way a person asks another person when they have been sitting with something too large to carry alone. I thought about Vasquez and her terrible coffee. I thought about her absolute refusal to stop at the size of the problem. "We get busy," I said. He wrote it down. I don't know why. It's not the kind of thing that belongs in a debrief record. But he wrote it down, and I was glad he did because I meant it, and meaning things is worth recording. I went home after that. First time in 8 years I had a place I could call that. A small apartment on the coast with a view of the water. I sat on the balcony in the evenings and watched the light fail over the ocean and thought about the dark at the edge of the solar system, and about the old, slow thing moving through it, and about all the things that had lived and died in the time it had been turning. I found myself reading things I hadn't read before. History, mostly. Not the kind I'd learned in school, the kind that concerns itself with the rise and fall of empires, with names of rulers and outcomes of battles, but deeper history. The history of life itself, the long record encoded in stone, which tells its story not in years but in layers, and in what is present and what is absent. I read about the Permian world in more detail than any of our mission briefings had required. About its shallow seas and its dense, fern-heavy continents and the creatures that had ruled it for 50 million years and then, in a geological instant, been mostly gone. I read about the recoveries. That was the thing that surprised me most, reading it closely for the first time, not the extinctions, which I had been thinking about for months, but the recoveries. Because each time after each clearing, life came back. Not the same life. Never the same, but something. Something that had survived in whatever corner of the world the clearing had missed. Something small and positioned by luck or biology to make use of what the clearing had left behind. It had come back, filled the world again, and built something new out of what remained. That happened 5 times in the record we can read. 5 major clearings, 5 recoveries, 5 cycles of loss and return, and each recovery produced a world that, in its complexity and vitality, was arguably not lesser than the world before it, only different, only new. I'm not naive enough to find comfort in that on behalf of the things that died. Dead things don't benefit from their successors, but the pattern itself says something about the character of the system as a whole, about what it is and what it has apparently always been, and what it is going to keep being regardless of any schedule. Stubborn, that's the word. Life on Earth is stubborn in a way that has survived 5 encounters with the traveler's gravitational influence and come back from each one. We are the current expression of that stubbornness. We carry it in our biology and in our behavior, and in the specific, peculiar human habit of pointing instruments at the thing that might kill us and refusing to look away. I thought about the Permian creatures, about the moment, if there was a moment, if the end of a world has a moment, when the impacts came and the sky changed, and the chemistry of the oceans shifted and the threshold was crossed. About whether anything alive through it had understood, even in the most primitive sense, that what was happening was not random, that it had happened before and would happen again. They didn't, they couldn't. They were alive in only that moment, responding to only that moment, with no instrument to point at the cause and no word to name it with. They died without knowing what had killed them. That's the difference. We can know. We already do. And knowing is the beginning of the only kind of fight that could ever matter, not the fight of a single generation against a single crisis, but the fight of a species against the long clock. Patient, stubborn, willing to build things we will not live to use, for people we will not live to know, against a problem whose consequences our grandchildren's grandchildren will not live to see. I look at the stars in the evenings now. I've looked at them since I was young enough not to know what I was looking at. But now I look at them differently. I look at them the way you look at a problem you've decided to keep working. Not with fear, not with despair, with the particular attention of someone who knows there is a long way to go and has chosen, deliberately, not to look away. Somewhere out there, in the direction I know now by the numbers, the old, cold thing keeps moving. And we keep watching. That's the job. That was always the job. We just didn't know it yet.